All right, guys, so this is like the 13th time I've tried to record this video. I tried it at school, I've tried it at home several different ways, and so I am so sorry, but we are straight up going old school to the way that I did do it. Welcome back to my kitchen table. All right, so I had a sick kiddo today after school, which is why I didn't get this up right after school, and most likely you are watching this during class and I am not there. So, sorry about that. I look forward to getting back on normal schedule here before spring break, but we've got a lot of learning to do, so let's get down to it. All right, so today we're going to start Module 5, Lesson 6, and we're going to find the total volume of solid figures composed of two non-overlapping rectangular prisms. So some of this we're already familiar with. Find the total volume of solid figures. Okay, boom. We've been doing that. That is absolutely nothing new. You guys should be experts at that. The next part says composed of. So that means made up of. So think about if you compose something, like you compose music, it's made up of different notes, right? So these shapes are going to be made up of two non-overlapping rectangular prisms. So this is, of course, a rectangular prism. All right, just a 3D rectangle. I know, my drawing's not to scale. Don't get too mad at me here. So what does non-overlapping mean? So non-overlapping, if I had two shapes, I do not have my Unifix cubes, so surprise, you get Mega Bloks tonight. If these two shapes were overlapping each other, it would look like this. Like one would be kind of over top of it, but it would hang off the edge. So when we talk about non-overlapping or not overlapping, that means that when I put the shapes together, they have one smooth edge. Okay, so that's going to be really important to what we're doing today. So we're going to look at these shapes that have a smooth edge like this. Now, when we work with shapes and what we've been working with so far, we've been able to find the volume of the whole piece. But as you can see from this shape here that I have, this isn't a whole piece. This isn't all even. This isn't all filled in. There's a huge gap here. And so I cannot simply just find the volume of one whole rectangle here. I'm going to have to put this together like a puzzle. Some of these puzzles are going to go together a lot easier than others. Some of them are going to require you to think, which I know that you are all possible of doing. So you're just going to have to pay attention and buckle your seatbelt and get ready. So we're going to start here with this first block. And so we're going to find the volume of these two separate shapes, okay? So here's where our imaginations come in today. We're going to pretend like these are my 4 Unifix cubes, okay? So if I'm looking at my 4 Unifix cubes, then when I look at how wide it is 1, 2 wide. We're going to call them centimeters. They're not, but we're going to call them centimeters. And then I look back at how many rows do I have? And I have 1, 2 rows. Now I have to look to see how many layers do I have. These are the tall blocks, but there is only one layer. So I multiply 1 times 2 times 2, and the volume of this shape is 4 cubic centimeters. Okay, that's what we've been doing already. Then I have a second shape. And on my second shape, the first thing I'm going to do is count how many across we're going to have. We're going to have 1, 2, 3, 4 centimeters wide. I have 2 rows of that centimeter. And if I look at how many layers I have, I flip these up on the side, and I actually have 2 layers of this.